The next model we're going to discuss is the Wilkins 950 series. 950 was a double check assembly produced in sizes 3/4 through 10 inch. The 3/4 through 2 inch was a bronze body unit in a Y pattern poppet style device. Production began on this about 1990. The 2.5 through 10 inch sizes were a cast iron body fused epoxy coated. Production began around 1990, but they were discontinued in the larger sizes around 2004. Check springs were contained on the larger sizes, meaning the 2.5 through 10 inch when the cover was removed, but the 3/4 through 2 inch had an uncontained spring when the check covers were removed for a repair. Important to know that the Wilkins model number 950 means a double check, but they've got these little letters afterwards that mean several different things. The 950 was the original produced unit that had a non-replaceable check seat in the 3/4 through 2 inch. They produced a model 950A in the 3/4 through 2 inch, which had a replaceable bronze seat, and then they produced a model 950 XL in the 3/4 through 2, which had a glass-filled Norell seat. In the 2.5 through 10 inch, the model 950 was produced, had replaceable seats on all sizes, but that was the flange unit that was cast iron body fused epoxy coated. Here's a picture of what the 950 XL 3/4 through 2 inch looked like. Inlet outlet shutoff, first check pointing up, second check pointing down in that Y pattern poppet style configuration. Here's a breakdown of the 3/4 through 2 inch design. Again, inlet outlet shutoffs, first check, second check, covers unscrew from the top. Spring is not contained when it's disassembled. One screw holds a disc in the disc retainer. The XL version had a replaceable glass-filled Norell seat. The 950A had a replaceable brass seat, and the 950 in the 3/4 through 2 did not have a replaceable seat. They also produced an XLT, T standing for top entry, where the parts were very similar to the 950 XL. Except that the checks were oriented from the top in case somebody wanted to put the double check in the ground or someplace where it was flat and have access from the top. The rubber repair parts are the same, but not all internal parts are the same. In fact, the check seats are different between the XL and the XLT design. The 2.5 through 10 inch, as I mentioned, was a cast iron fused epoxy coated, single access for each check from the top. Check springs were contained for the average repair. You'd remove the cover off the top, the spring would stay contained, the check assembly would come out in one piece for repair. Here's what the 950 looked apart in an exploded view. Again, first check, second check. Check assembly came out in, or the check spring was contained. Check seats were bolted into the body and sealed by an O-ring before replacement. But the check spring did not have to be released for the average repair. Usually all you have to do is replace the nut or bolt on the inlet side, depending on the size of the check mechanism. One check flat, the disc would be replaced, but the spring didn't have to be removed for the average repair. Spring was contained. They did produce a model 950DA, a detector assembly, double check detector assembly version, inlet and outlet shutoffs. Same basic body on the main valve as the 950. Spring loads different for the workings of the detector assembly, and the 950 uses the bypass on that assembly. 950DA was produced in sizes 2.5 through 10 inch. Like many manufacturers, they produce a double check and a reduced pressure assembly with the same check mechanisms. So the checks we saw in the 950 series are the same checks similar checks we're going to see in the 975 series. And just like with the 950 series, we have a lot of letters that mean a lot of different things depending on which model we're dealing with. On the 3/4 through 2, the original model was a 975. It did not have replaceable check seats. They then produced in the 3/4 through 2 a 975A, which had a replaceable bronze seat, and then they produced a 975XL, which is still in production today, with a replaceable glass-filled Norell seat. The larger sizes, 2.5 through 10 inch, were produced in a same construction as we saw in the 950 with the fused epoxy coating. Check springs were contained for the average repair, but they also produced something called an MS, which is a monitor switch, which I'll show you in just a second. Here's a picture of the 975XL in the 3/4 through 2 inch sizes. Inlet outlet shutoff, first check pointing up, second check down, that Y pattern poppet style construction, relief valve cover underneath, relief valve stem assembly inside the body, no external relief valve sensing line. The sensing lines were were internal for the relief valve. Here's a schematic of the 3/4 through 2-inch size inlet outlet shutoff. Our first check pointing up, second check down, showing the parts of the check assembly. Our check seat, which stays threaded into the body, sealed by an O-ring. Check disc holder, check spring, screw-on check covers. So when you remove the cover, spring tension would be coming up underneath the cover. Relief valve stem assembly here, mounted under our body. Relief valve stem assembly and our relief valve cover on the 3/4 through 2-inch. As I mentioned, there was an XLMS for monitor switch, and what this monitor switch was a solenoid that was bolted into the relief valve cover. And the purpose of this monitor switch is that it would send out a signal when the relief valve stem would stroke wide open. So when the stem moves out on the relief valve, it would hit the solenoid, which would send an electronic signal to something, either to a automatic dialing machine, to a bell and a whistle, to a pump to shut down, some way of making sure somebody knew that this relief valve was discharging. This had some good applications in areas where water was critical and couldn't be discharging out of the relief valve, or when it did discharge, somebody wanted to know immediately. They also made a battery version of the monitor switch, the battery monitor switch, or the hardwired electronic version. The larger size 975 in sizes 2.5 through 10. Inlet shutoff, outlet shutoff, same check mechanisms we saw similar in the 950, different loads obviously. Relief valve assembly was mounted on the side of the check body, had internal relief valve sensing lines, so there wasn't a tubing that had to be removed for the average repair. Same cast iron construction, fused epoxy coated as we saw in the 950 checks. In the 2.5 through 10-inch size, here's where the relief valve was mounted on the side. Here's the exploded view of the relief valve body, relief valve seat, our relief valve disc, relief valve stem, stationary spacer and mounting O-ring, relief spring, our spring retainer, relief valve rolling diaphragm, diaphragm retainer, and relief valve cover. Those are all mounted inside the relief valve, mounted on the side of the check bodies. Check bodies, same as the 950 series first check. Check springs were contained for the average repair. When the cover came off, the spring would be contained underneath. Didn't have to be disassembled for the average repair. Just changing the check disc did not require a release of the spring tension. They did produce a model 975, which is a reduced pressure detector assembly. Main valve meaning the 975 assembly, and the bypass 975 also in a detector assembly version. So the 950, 975, and the corresponding detector versions, 950DA, 975DA in sizes 2.5 through 10. They did make the small 950 and the 975 in the smaller sizes, 3/4 through 2. They also produced the 975 in smaller sizes, 1/4, 3/8, and 1/2 inch also. So let's go ahead and take the 950, 975 series apart and take a look at the checks and the relief valves. Here's a cutaway of the 975 XL on the right side here, and here's the same thing with the monitor switch attached, just to show you what it looked like inside. We're going to take this apart in sizes. The 3/4 through 2-inch are very similar construction, so we'll talk about that one first, and then we'll talk about the large flange stuff, 2.5 through 10, second. Let's go ahead and rebuild the 3/4 through 2-inch, actually the 1/4 through 2-inch sizes of the 975 XL. We'll do the Y, it has the Y pattern poppet style checks like we've seen in several other designs before with the relief valve mounted underneath. A lot of times we say we want to look at an assembly before we start taking it apart, and there's one on this. Here's what the full side, non-cutaway side looks like. One thing that you want to observe closely on this when you're testing it and rebuilding it is on the relief valve cover. In the center of the cover, what you're going to see is a very small little breather hole. And it's very important that that's open, clear, making sure the relief valve works. There should not be water discharging from it, and there should not be things all built up around it. Or I've seen places where people sell the hole and they thought there was a problem with it and shoved a screw in there, trying to stop it when the water was leaking. It should be perfectly open like that, and that's what we want to be able to see. Being a cutaway, it's kind of hard to tell. But anyway, back to this. So let's go ahead and take this apart. Check assemblies. Covers unscrew from the first check pointing upwards. We have our disc holder. Here, our disc holder, our spring, and our check cover. Second check pointing downwards. Spring tension will come out. Check spring, cover, and disc holder. And the check seat came out. Check seat is obviously replaceable on this model. Check seat requires a special tool to get in. To remove it, the tool goes in the center, allows you to twist it to unscrew it or screw it into the body. So let's talk about the check assemblies first. We've talked about the Y pattern poppet style check with several other designs, and we'll do it one more time just to be safe. First of all, how does the check assembly work is the most important thing. This is what the check assembly would look like inside the body, like that, in a closed position. And as there's a demand for water, the check would travel into the guide. Going to close action, it would come out just like that. Unfortunately, when this is repaired by the average repair person, it's repaired incorrectly many times. This is a plastic material, so it's not going to be susceptible to corrosion, but does have scale buildup. And some growth will be on here or some kind of irregularities. And a non-knowing technician will take a piece of sandpaper from his copper bin and just sit there and shine that up thinking he's making it real smooth on the outside. Never, ever, ever put any kind of sand cloth on this. Remember our rule, nothing more aggressive than the material it's made out of. This is a case where those popsicle sticks come in handy, old credit cards, something that's softer than the material you're trying to clean is what you want to clean that with, never sandpaper. And for some reason, these guides, which is part of the check cover, people say, oh, half-inch copper fitting brush fits in there real good, and you'll see them shove a copper fitting brush in there to try to clean that out. Same story. Never anything that aggressive. Something like a Scotch-Brite pad, the non-metallic type, something like a popsicle stick, as I mentioned earlier, getting in there and cleaning out any scale that's built up or checking if any corrosion has taken place. If it's corroded to the point that it's damaged that seating surface, the cover may have to be replaced. In other words, this is not just a drilled hole. If you stick your finger in it next time, you'll feel that it's very smooth. It's what's called honed. It's a polishing action that makes that very smooth. Because the working of this check mechanism, although it looks simple, unfortunately, sanding here or sanding there can affect its working. Another thing that's common you'll see is that people will see how this slides in here and they think, oh, if you put grease in here or grease on this stem, it'll slide much easier. That is not true. That actually will restrict its travel and make it wear out a lot sooner. Let's talk about how this is working so we have a better idea why we don't want to do some of those things. As I mentioned a minute ago, this is the working action of that check assembly. In other words, that's in a closed position. As there's a demand for water, it'll travel into the cap. I'll take the spring off and let's do that again now. So if that's what it's like in a closed position, water's turned on, first thing I want you to notice is that the stem is hollow. In other words, there's a hole through the center, and there's a corresponding another hole at the base right there called a breather hole. So if this is sitting in that valve like that with the spring between it, and its water's turned on, water will travel through that breather hole into the center of that stem. It'll also travel in the differences between the outside diameter of this stem and the inside diameter of this guide. So that area in there is full of water at this point. As the check assembly opens and the check goes into the guide, the water that's in that cover has to come out somewhere. So where it comes out is either between the breather hole or between the outside diameter of the stem and the inside diameter of this guide. The tolerances on this is very, very tight, literally within thousandths of an inch. So it's important that there be no restrictions as the stem travels back and forth. In other words, when it travels into the cap, the water that's in the center of that stem comes jetting out. In other words, the water jets over this stem around this guide. It acts as a lubricant. So it is a self-lubricating check mechanism when nothing interferes. By putting grease along there or by taking sandcloth and roughing up this side, you're making it so it doesn't travel as easy and actually causes it to wear out faster, and that can change your differentials on that check. So let the water act as the lubricant. Do not put any other kind of lubricant on it. Oils, paste, nothing. Anything that interferes with those tolerances will cause it to not work properly. So make sure you've got that moving smoothly through its travel back and forth. Now earlier when we were talking about how we're going to repair an assembly, remember I said we put the first check assemblies here, second check and relief valve. We put each component in its group. The reason we want to do that is because when we put it back together, we want to make sure that those parts go in the same component because we want to determine what caused that failure. And if we put them all the way back together and we still have that same type of failure, then we can start looking at the parts to see what might be damaged inside. Anyway, so one screw holds the disc into the disc holder. Go ahead and replace our disc, and having it ready to go back into the body. Now let's talk about the relief valve. Relief valve, and that's what a whole relief valve cover would look like, rounded like that on the bottom. Obviously we have a cutaway version. We're going to go ahead and remove our relief valve cover bolts. There will be spring tension underneath. So once I remove those bolts, hang on to the cover. I mentioned earlier, checking that breather hole is very important to make sure it's open. Relief valve cover comes off. Relief valve stem comes out next. Relief valve spring. And my relief valve threads into the body right here, held sealed by an O-ring on the back side. The seat does not have to come out of the body for the average repair. So these are the parts of the relief valve. Let's see, how does it work. Why was I so worried about this breather hole on the back of that cover? Well, if you'll notice, there's the back half of my relief valve stem. Here's what the 2-inch stem looks like. There's a back half, and then there's the front half that has its relief valve disc, like you see here. The way this assembly works is that relief valve is guided by, on the front half, see the legs on the seat, as it moves back and forth like this. The spring sits between it like that, but it's also guided on the back by the cover. Notice the O-ring that sits right in there on that cover. So this breather hole is there because this area is dry. It is not open to water on this back side. In other words, the high pressure sensing line brings that our high pressure on this side of the diaphragm. The low pressure sensing line comes through the body down here and puts the low pressure sensing line and fills the body back here for its low pressure. So this is a guide just the same as this is a guide down here on that relief valve seat. So it's a double guided relief valve stem assembly. So that's why the cover is so important, because that way that cover sticks out now. Let's talk about a whole cover. Would look like that. What would happen if somebody had put a pipe wrench on that spot when they were assembling it, or somebody hit it with a baseball bat, or somehow they bent that? You can see if that was bent in any way, or if something happened to change its shape, that stem could be gripped by that cover and may not move easily. So that's why I want to check that breather hole. I want to inspect the cover on the outside, making sure there's no markings of any kind on there, and making sure nobody has bent or damaged that cover before we got to take it apart. Okay. So that's the parts of that relief valve. I'll take the 2-inch stem apart. It's a little bit bigger and easier to see. One screw. Relief valve disc retainer. Comes apart. Stem assembly, diaphragm, outer stem. Here's that O-ring on the back side of that relief valve stem, the part that slides into the cover. No, I don't suggest you take screwdrivers to O-rings like this, but just trying to show you what the O-ring looks like off of that stem. So reassembly, proper lubricating an O-ring, put the grease between your fingers, wrap it between there, making sure properly lubricated. Put the O-ring around, make sure wiped properly. Relief valve diaphragm again, stem, relief valve disc retainer, assembly bolt. Go ahead and get it hand tight. Now as we tighten these two pieces together, it's very important that this screw be very tight. We're facilitating a water seal across this diaphragm through this screw. That means we don't have the assistance of an O-ring. So we've got to tighten that down very tight to make sure that it's not leaking across there. Once we have our stem assembly ready to go back into our body, we have our relief valve spring first, relief valve stem. Taking our relief valve cover, we want to make sure that we know the relief valve high pressure sensing line goes through the diaphragm. So we want to make sure that hole lines up just like that, making sure that we don't block off. You can see if I rotate that over, blocking that sensing line, the relief valve will never shut off because the sensing line through the cover, through the body, will be damaged. Be covered. So make sure that the hole there corresponds with the hole on the relief valve. When you reinstall that relief valve stem, the other thing you want to check besides that diaphragm hole is making sure that the diaphragm is the right direction. And what I mean, if you'll notice when you lay the diaphragm over the cover, that the bolt holes will line up just like that with the holes in the diaphragm. Now watch what happens when I flip it over. Guess what? Now they don't line up. So it's important to take the time to make sure we have the diaphragm in the right direction so that the bolt holes will line up. And it's a matter of taking that diaphragm, lining it up, make sure that you have it in the right direction. Okay. Back to reassembly. Line up our relief valve sensing line with our relief valve cover. Ready to go back into the body. Cover bolts. It's always a good idea to put the cover bolts through the diaphragm before you go stretching it, because look what's happening. I'm pushing against this relief valve spring, and as I push it down without a cover, that diaphragm stays perfectly flat. But when I push it with this, notice how that it curls down into the valve. That's because it's pushing on that relief valve diaphragm itself. So by placing all the bolts through the relief valve cover through the diaphragm, it makes it that the diaphragm will stay flat. And it also helps you catch the holes for the relief valve cover onto the check body. Now you want to put the check assemblies back in. Remember, we said the disc holders were interchangeable. They're the exact same first or second check. But we want to keep them separate in the assembly process just to find out if we're going to have any issues with the check disc holders being slightly bent or damaged, which by keeping them consistent within the checks in our repair process, we can tell if they're working anyway. So now, once we have the check assembly, you'll notice with a cutaway we can see this pretty easily. As we go to rotate this disc, you'll see where that spring turns. You'll see here like the disc holder may turn sometimes. Very important to make sure that as we start getting this, we try to feel on the cover if there's any movement inside there, and you can actually tell when it moves there, because we don't want to torque that spring, and we just don't want to torque that disc on there. A little more common on second checks because the spring tension is less and there's not as much load against that. Very common on the very small, meaning quarter through 2-inch size small, quarter through half-inch size small assemblies. But you can see there as that spring rotates like that slightly when it turns. We want to be careful when that happens, because what happens when that spring turns in there is it may be cocked to one side. So after we go to turn this assembly back on, obviously we've got to pressurize it again, return on. Before we go to test it and before we turn on our number 2 shutoff, is open our number 4 test cock. Because what I want to do is I want to get the check assemblies to open. And by getting the check assemblies here to open off of their seating mechanism, it allows it to make sure if there's any torquing action on that spring or that's been pushed onto the disc, onto the seat, that we take it off there. It allows it to straighten itself out and then sit back straight onto the seat. So once we've got our check assemblies back in, go ahead and repressurize it slowly, as I say, and make sure we flow a little water before we run our test. And if we do everything correctly, that should be a properly working Model 975 XL. Here's an actual 975 4-inch Wilkins assembly. First check, second check. Cast iron body fused epoxy coated. See the bolts covered on the top. When the bolts come off, check assembly, the spring is contained underneath the check cover for the average repair. Relief valve assembly is bolted on the outside of the body. It does not use external relief valve sensing line or tubing. The sensing line goes internal. I'll show you that with the relief valve. Relief valve body does not have to be taken off the check body for the average repair, just the cover removed and the guts removed, which we'll do in just a second. But that's what the 975 large size, meaning 2.5 through 10-inch, looks like in an actual assembly. Here's the check stem from that 4-inch 975 check assembly. Check assembly will come out in one piece just like this for the average repair. Again, the body was cast iron with fused epoxy coated. The check seat is bolted into the body and replaced by a number of bolts sealed in by an O-ring. Check seat doesn't have to be removed for the average repair. The average repair would just usually entail removing this nut, my disc retainer, take my check disc out, put my new disc back on, and making sure my disc is perfectly flat in my disc holder, disc retainer nut, tight. That should be the average repair. But let's say we did that and we still have a problem with our check assembly, and we start looking closely, the seat looks fine and everything looks good in there. As I said, the spring is contained for the average repair and should not have to be replaced. But should you have issues beyond all of those other things, I want to show you one thing that is not part of the normal repair and not seen, unfortunately, is on the back of this check stem, there's an O-ring right there. And it makes sense because that O-ring, that disc stem goes into the disc holder, and that O-ring seals it where that stem travels through there. So if that was not properly loaded, or if it was cut or nicked, or somebody took it apart, or somebody turned it a couple of times and made it so that it wasn't completely loaded on the back side and changed, that O-ring could cause a leak. Be it rare, it still could happen. So be aware that it's back there because it gives you something to look at. You can see the bushing on the back half of the spring retainer with the second bushing that corresponds in the center of the check seat. Reassembly is going to be just the reverse. Again, we shouldn't have to remove the spring tension for the average repair to change the rubber disc. The only reason you'd have to do that is if that O-ring required replacement. And that's the check stem assemblies out of the larger 950 double checks and 975 reduced pressure assemblies. Here's the relief valve from the 975 series. As I said, the relief body does not have to come off of the check body. It's attached by bolts down here. It can stay on the body. Just the cover has to be removed. Here's my high pressure sensing line. I told you it did not have an external tubing. It actually has a chassis through or a passageway through the body right here, which makes my high pressure sensing line. And if you were looking in from the check side, that's what the relief valve disc would look like. But you notice in the center of that bolt, in the center of that, right in there, in the center of that, there's a hole drilled in it. That's our low pressure sensing line. That's where the low pressure gets on the low side of our elastic element, which I'll show you as we take it apart. So as I said, for the average repair, this stays attached to the check body. We remove our relief valve cover bolts. Once we remove our relief valve cover bolts, we see a rolling diaphragm. By grabbing the entire diaphragm in one piece, the whole stem assembly will come out in one piece. The relief valve seat is stainless steel and stays captured in the body for the average repair. If you had to replace the relief valve seat, 9/64 Allen head screws hold this. There's 3 of them that hold that relief valve seat in place, sealed by an O-ring underneath. So if the seat's okay, we take the seat, leave the body on there, and take a look at that later. Here's where my low pressure sensing line comes in, follows up through the bolt hole through the center of that stem. So the first thing we have to do is remove our relief valve disc retainer bolt. After we do that, turn it over. We have a second bolt that holds our relief valve spring. Go ahead, remove that. There will be spring tension underneath. Upper bellow-frame, rolling diaphragm plate, rolling bellow-frame, lower bellow-frame retainer, relief valve spring, relief valve stem, and stationary guide. It's an O-ring stem design, as you can see, just like we see on some of the other manufacturers, where that O-ring is mounted in the center of the stem and travels through a stationary spacer in its travel. So as it moves back and forth, that's how that stem action operates with the diaphragm on the back side. Low pressure sensing line, as I said, comes through the assembly bolt of the disc with the hole on that side, corresponding hole in the head. Water travels up through here, comes out through the breather holes on the side of that stem, getting the low pressure. So here's where that low pressure water will come out on the back side of my elastic element. Okay, reassembly is going to be just the reverse. Replace my stem O-ring, my stationary guide O-ring, my stem O-ring, relief valve spring, lower rolling diaphragm plate, rolling diaphragm, upper diaphragm plate, bolt, O-ring is on the top of the stem, reassemble, catch that, make sure it's very tight, sealed across that O-ring so we have a good water seal. Turn over, put new relief valve disc retainer. Make sure you put the low pressure, the relief valve disc retainer bolt in there, that the hole is clear so that the water can travel through it. Reassemble back into our relief valve body. Going to go ahead and place our stationary guide into the body. Remember, we have to load that O-ring, so we push down on it. So I want to fold the rolling diaphragm up at this point, pushing down, engaging and loading that O-ring. Once I've got it down, all the way down in place, now I want to roll this large rolling diaphragm down carefully. Anytime you have a rolling diaphragm, it's critical that we have that rolling all the way around, that rounded shape like that, because if it doesn't, it's going to crink to one side and it's not going to travel its full length. Stroke it again to make sure you have good movement of your rolling diaphragm. There is an O-ring that holds on the high pressure sensing line right here. Make sure you replace that O-ring. Relief valve cover bolts. And that's what the relief valve on our 975 large, meaning 2.5 through 10 inch, is going to look like.